Assalamu alaikum. Today my topic name is UV visible spectroscopy. Firstly, we preview about the UV visible spectroscopy. Spectroscopy is the branch of chemistry in which we study the interaction of electromagnetic radiation with matter. In UV rays absorb substance and the transition occurs. Next one is solvent effects, and the next one is factors affecting lambda max of inorganic compounds. The next is conclusion. Solvent effects. The choice of solvents to be used in UV visual spectroscopy is quite important. Highly polar, non-polar solvents such as saturated hydrocarbons do not interact with solute molecules either in ground or excited state, and absorption of compounds in these solvents is similar to the one of the pure gaseous state. However, polar solvents such as water, alcohols, etc. may stabilize in molecular orbitals. The choice of solvent is to be used in UV visible spectroscopy is quite important. That's why a best solvent is that one which possesses the following three properties. It should not absorb UV radiation in the same region as the substance whose spectrum is being determined. It should not interact with the solute. Sample whose lambda maximum is to be determined. It means that non-polar solvent that does not form hydrogen bond with the solute, thus a fine structure is often observed. In polar solvents, hydrogen bonding forms the solute-solvent complex and the fine structure may disappear. Its ability to influence the next one is its ability to influence the wavelength of UV light that will be absorbed. Stabilization of either the ground state or the excited state. Polar solvent shifts transitions of the N to pi star to shorter wavelength and shift transitions of the pi to pi star type to longer wavelength. Factors affecting lambda max. Only are the factors that affect the lambda max of an organic compound and hence are important in predicting the proposed structure for the sample. First one is chromophore, the next one is AUXOCHROME, the next one is conjugation. We see chromophore. A group of atoms that plot change in wavelength of radiation absorbed by the sample is called chromophores. This makes absorption of radiation to occur in longer wavelength and thus visible in the region of ultraviolet and visible spectrum. In this way, chromophore plays an important role in assigning a structure to the sample. Example, double triple bond, aromatic conjugation, and various functional groups such as RCOH, RCOOH, RCOOR, and amine group. AUXOCHROMES, the substituents that increase the intensity of absorption, is called AUXOCHROMES. Typical AUXOCHROMES include methyl group, hydroxyl group, alkoxy, halogens, and amino groups. Other substituents may have any of four kinds of effects on the absorption. The first one is orthochromic shift to longer energy or lower energy or longer wavelength. In this shift, its second name is red shift. Hypsochromic shift, its second name is blue shift. In this shift, a shift to higher energy or shorter wavelength. The next one is hyperchromic shift. It belongs to intensity. An increased intensity of absorption is called hyperchromic shift. And hypochromic shift is the decrease in intensity of absorption. The next one is conjugation. The best way to bring about better chromic shift is to increase the extent of conjugation in double bond system. In the presence of conjugate double bonds, their electronic energy levels of a chromophore move closer together. As a result, the energy required to produce a transition from an occupied electronic energy level to an unoccupied level decreases. The wavelength of the absorbed light decreases. It's important to note that conjugation of two chromophores not only results in a bathochromic shift but increase the intensity of absorption. These two shifts or effects are of prime importance in the use and interpretation of electronic spectra of organic molecules because conjugation shifts the selective light absorption of isolated chromophores from a region of the spectrum that is not readily accessible to a region that is easily studied with commercially available spectrophotometer. Example: CH3 single bond CH double bond CH. It's alternate and continue number of carbon atoms that is further attached with methyl group. So in this my lecture we firstly discuss about the solvent effects, and in solvent effects we see that the solvent has a three property that possess the best solvent is one which possesses these three properties and obey these three properties. The next one we discuss about the factors affecting. Firstly we discuss about the chromophore, then auxochromes, and the last one we discuss about the conjugation. That's one of the most important thing. So that's all of my today lecture. Thanks to watch.